Hello everyone, I'm Phil. I'm the one they send in when the smoke clears and the lawyers start pointing fingers. Today we aren't looking at a bridge that fell because of rust or a plane that went down because of a bird strike. No, today we are performing a digital autopsy on a $300 million pile of scrap metal that is currently scattered across the Martian atmosphere. The 1999 Mars Climate Orbiter was supposed to be the jewel of NASA's faster, better, cheaper era. It was sleek, it was efficient, and it was doomed before it even left the launch pad. It didn't fail because of bad luck. It failed because two groups of literal rocket scientists forgot how to talk to each other. They ignored the fundamental law of measurement. If you don't agree on the units, the universe will solve the equation for you. And the answer is usually an explosion. Let's get into the wreckage. Imagine you're building a giant Lego castle with your friend. You're using centimeters because you're a civilized human being, but your friend is using inches because they enjoy chaos. You tell them the bridge needs to be 10 long. You mean 10 centimeters. They build 10 inches. Suddenly, your bridge is way too big, it doesn't fit, and the whole castle falls into the dog's water bowl. That is exactly what happened to a $300 million spacecraft. To understand why the Mars Climate Orbiter, let's call it the MCO, vanished, we have to talk about something called small forces. In deep space, even a tiny nudge matters. The MCO had a giant solar panel stuck out on one side, like a person walking with one giant shopping bag. Because of this, the wind from the sun, solar radiation pressure, kept trying to turn the ship. To keep it straight, the ship used little wheels inside that spin really fast, reaction wheels. But eventually, those wheels get tired and need to be reset. This is called angular momentum desaturation, or AMD. Every time they reset, the ship's little thrusters would give a tiny, precise thump to stay on track. Here is where the toddler logic kicks in. The engineers at Lockheed Martin in Colorado, the people who built the ship, wrote software that measured these thumps in pounds force. This is the imperial system, used mostly by people who still think a foot is a valid scientific measurement. This data was saved in a file and sent over to the navigation team at NASA's Jet Propulsion Laboratory in California. Now, NASA is a scientific agency. They use the metric system, newtons. To NASA, 10 means 10 newtons, but Lockheed sent a 10 that meant 10 pounds. Here's the catch. A pound of force is 4.45 times stronger than a newton. It's like telling someone to tap a glass with a spoon, but they hit it with a sledgehammer instead. Every single time those thrusters fired over the 9-month journey to Mars, the ship was getting kicked 4.45 times harder than the navigators thought. For 9 months, the MCO was quietly drifting off course. It wasn't a big, obvious drift. It was like a car with a steering wheel that's slightly crooked. You won't notice in the first block, but after driving across the country, you'll end up in a different state. NASA thought the ship was on a perfect path to skim 226 kilometers above Mars. In reality, it was diving straight for the ground. On September 23, 2009, the MCO reached Mars. It had to hide behind the planet and fire its main engine to slow down. If it was too high, it would fly off into space forever. If it was too low, it would hit the atmosphere and burn up. The safety zone was 80 kilometers high. NASA thought they were at 226. They were actually at 57 kilometers. When the ship hit the Martian atmosphere at 57 kilometers, it wasn't like a gentle breeze. At that speed, the thin air of Mars acts like a solid wall of fire. The heat instantly ripped the solar panels off. The heat likely melted the gold foil and the delicate sensors. The MCO didn't land, it vaporized. It became a very expensive, very fast-moving cloud of glitter. Why didn't anyone catch this? Because the people in charge were too busy trying to be fast and cheap. The navigation team actually noticed the ship was acting weird. They even talked about it in meetings. But because there was no official way to check the math homework between the two teams, the error stayed hidden in the code. No one bothered to check if 10 meant 10. Alright, let's look at the wreckage one more time. Lockheed Martin used pounds, imperial. NASA used newtons, metric. 1 pound is 4.45 newtons. Nobody wrote a conversion line in the code. The ship got kicked 4.45 times too hard for 9 months. A $300 million satellite turned into space dust because of a math mistake a third grader could fix. Now we want to know about you. Did you know that a missing 4.45 conversion factor was enough to turn a NASA masterpiece into a shooting star? Let us know in the comments below. It's a miracle we've made it this far as a species, honestly. This audit is closed. If you want to see which multi-billion-dollar project is currently being held together by hope and a lack of oversight, like and subscribe. And remember, check your data units, it keeps you alive. See you in the next bowl.